Hello students, in this session, we will see JEE sums from the chapter Motion in a Straight Line. As I've already told you in the introduction video, I've just told you that we will see JEE questions. Got it? I wouldn't be able to solve all the questions from the JEE, previous year JEE. Okay, that's not possible because for a chapter, for a normal chapter, you get around like 150 questions. If it was like a heavy weightage chapter, you get around like 400, 450 questions. It's not possible to solve all those questions and then it will be tiresome and boring. Fine, so you get that same pattern. Okay, so same kind of pattern will be repeated multiple times. I wouldn't be able to do all those solving. That's not possible. So what I will do is I'll just randomly choose different sums. Got it? I won't randomly choose. I'll just peculiarly choose like different pattern sums that weren't oriented, that we have already seen in the neat pattern sums and all, right? So that's going to be completely different pattern, right? Got it? Same way, the same pattern that has already been repeated, which we have already seen in the need based question. I'm not going to do that sum, right? So that will be your part to do the solving. Fine. So for this chapter, I have chosen around like 35 to 40 sums. I'll do those 35, 40 sums. Once you are thorough with all those pattern, then obviously rest all other sums will become easy for you to solve. You just need to know that critical thinking and the solving method. Okay. So that should be done from your part. Got it? So every question that I'm going to solve will be from JEE. Okay. Same way, I'll also attach a attachment file in the description section of this video. So what you have to do is you just have to download that question paper and then you have to work on all those questions. Okay, those questions will also be from the previous year question. So depending on the chapter weightage, I'll just attach those questions. Okay, on an average you'll get around like 40-45 questions. I'll also give you the solution. So if you are thorough with all the pattern sums that I've taught you along with the neat type questions, okay, so those questions is also tough. So JEE and neat, those two examination have almost similar level of difficulty. Okay, but the point is here you have to work hard with the mathematical solving, right. So this JEE examination is one step ahead, that's for sure, with the case of solving and then the understanding. But neat question is also equally competent. Okay, therefore first you have to go through all the questions that I've taught you in the neat. Same way I have taught you different pattern sums that I have asked for you in the JEE examination. Once you are thorough with all those pattern, okay, you will be ready to solve all the different kind of sums that they have asked you in the examination. Okay, so in the video description, you will have that extra attachment file that will be the practice paper for you, which you need to solve. Got it? So in that practice paper, same way I'll attach like 40-45 questions. Those questions will also be from the JEE previous year questions. Got it? I'll also give you the solution. If you are thorough with all the stuff, okay, all the questions that we have done for a particular chapter, then it is obvious you'll be able to do any sums that they ask you in that chapter, right? So one or two sums might miss, but it's completely done. Okay, all the different pattern would have been done at that point, right? Obviously you can create like n number of questions. It's not possible to solve all those different pattern and things of that sort, but you would have come to a point where you will get that confidence. Okay, this is enough for this particular chapter, and then we will be able to crack that examination. Okay, so that's the confidence that I wish to give to the students, right? Fine. So this is something that you need to know before we jump into the question. Let's jump into the first question. The first question over here is what they've given is you have got a clock has 75 centimeter, 60 centimeter long second hand and minute hand respectively. So this is a clock which has 75 centimeter second hand. So we obviously know second hand will be longer when compared to the minute hand. Then yeah, the shortest one will be the hour hand. Okay, so here we are just comparing only two hand, which is like second hand and then the minute hand. We are not going to consider the hour hand because they haven't given any detail regarding it. Fine, so the first statement has to be clear. Then they have given us in 30 minutes duration, the tip of second hand will travel x distance more than the tip of a minute hand. So in 30-minute duration, so I'll have to consider a duration of 30 minutes. Got it? If initially it was at 12. For example, the minute hand and the hour hand, I mean the minute and the second hand was at the 12, okay, which is 12 o'clock. Then after 30 minutes, the minute hand will show you like 12:30. Same way, the second hand would have covered like 30 revolution in the clock, right? Got it? It should be obvious. So what they've given us over here is in 30 minutes duration, 30 minutes, therefore the second hand would have covered 30 revolution in the clock. In 30 minutes duration, the tip of the second hand will travel x distance. So what they're asking us is not is the distance, not the displacement. If it was like displacement, then it would have been at the same position. As far as as far as the minute hand, the second hand is considered, it would have been in the same position. But with the case of minute hand, it would have covered half the circle. Okay, something like that. Got it? The tip of the second hand will travel at x distance more than the minute hand. So what they're asking us to find is the difference between the distance covered with the case of second hand with respect to the minute hand. Okay. If it was the displacement, it would have been an easy one because the second hand will be at the same initial position after completing 30 revolution. But with the case of the second hand, it would have covered like half the circle, right? So it will be at the exact opposite position. So the final minus initial will give you the displacement, but they're not asking us to find the displacement over here. So this is more kind of mathematical solving based sum. Okay, so the solving will be linear. That's it. So what they're asking us to find is the distance, which means I'll have to stretch that complete circular circumference motion into a straight path, and then I'll have to do the subtraction, right? Got it? Okay, so that's what I need to get over here. So what they're asking us to find is the value of x in meters nearly is. Okay, so here I'll have to find the difference between the distance covered by the second hand with the distance covered by the minute hand. Okay, that's what I need to get over here. So I have to get that one. First, I just need to know, the how far the second hand has traveled, because second hand would have traveled much more farther when compared to the minute hand. That's obvious, right? So let me do the solving over here. If I have to get the distance covered by the second hand, it will be equal to circumference of the circle multiplied by the 30, right? Because the 30 minutes have passed, which means it has completed 30 revolution, isn't it? Therefore, distance covered by the second hand, isn't it? Now let me write it this way. Distance of the tip, right? So I'll have to consider the tip. So distance covered by the tip of the second hand. Second hand. Okay. Which will be equal to 30 minutes, yes, multiplied by the circumference of the circle, which will give me 2 pi r, isn't it? So you'll have like 2. Instead of pi, they have told you I'll be able to substitute like 3.14. Let me do it. So then multiplied by 3.14, and then I'll have to put the r, isn't it? So for r, what they're given as in the question, it is equal to 75 centimeter for the second hand. See, if you just look at the option, I'll have to get the answer in terms of meter. Therefore, let me convert this 75 centimeter to meter, which will be 0.75 meter, isn't it? That should be obvious. So here, the next multiplication that I need to do over here is 0.75, right? So this is the distance covered by the second hand. Then I'll have to get the distance covered by the minute hand, okay? So then for the minute hand, it will be distance covered by minute hand. Minute hand. Okay. If I have to consider that one, that will be the half the circumference of the circle, right? Because in 30 minutes, if it was at 12, then it would have covered 12:30, right? It would have covered 30 minutes, which will be half the circle or semicircle. So circumference of the half of the circle will be half times 2 pi r. That will give you something like this. Half multiplied by 2 into 3.14 multiplied by the length of the mid hand, which will be 60 centimeter. That will give you 0.6 meter. Okay, just do the subtraction of second hand minus the minute hand. You will end up getting the distance covered. Okay, now let me do the subtraction. If I do the subtraction, you will have, just let me factor out the same numbers. So you would have got 2 in both those situations. Same way you would have got 3.14, and then just left over, it will be inside the bracket. I'm just going to do the difference between distance covered by second hand subtracted from distance covered by the minute hand. Okay, so if I have to do the difference, you would have got 2 into, let me take a different color over there. You would have got 2 into 3.14, then inside the bracket, you would have been left with 30 into 0.75, 30 into 0.75, yes. And then here with this case you would have got subtracted by half, yes, it will be 0.6, yes, multiplied by 0.6. Got it? See, now let me look into the options. If you look at the option, it should be obvious. These 220, if you compare 220, 118.9, these numbers are further apart, okay? Therefore, these are not closer values, right? Even if you do the approximation, you'll end up getting the right answer. But if you look at the option 1 and 3, so that's the closest value, 139.4 and then 140.5. If you end up getting the value that is close to 140, things of that sort, then obviously it is not possible to choose whether it is option 1 or option 3. Therefore, in this situation, you'll have to solve exactly. There shouldn't be any approximation as much as possible. That is when we will be able to pick the right answer. If all the numbers were good further apart, then that wouldn't be any problem in doing the approximation. But in the situation, there are like two options which is closer. Therefore, it is like extremely closer. Only difference is 1. Okay, the difference between those two options will be 1. Therefore, you shouldn't do any approximation while solving this sum, right? I've told you clearly, approximation is not allowed. Okay, so let me do the solving over here. So if I have to do the solving, let me cancel out to 0.6. That will give you 0.3 over there. And then you would have got like 0.75 multiplied by 3. That will give you 75 multiplied by 3, isn't it? 15, 1. 7 multiplied by 3 will be like 21, 22, right? So 225. If I do move the decimal places 0 and then 1, I'll just have to move one decimal places towards the left, so it will be like 22.5. So the answer, so here you would have got like 22.5, isn't it? So here it's like 22.5 subtracted, you'll have to subtract it with 0.3. So if I do subtract these two values, I'll end up getting 22.2. Yeah, right? Yes, 22.2. Now I have got this 22.2. I'll have to multiply it with 3.14. Then I'll have to multiply it with 2. So let me do the multiplication of these two stuff. It will be 8, 2.6.28. Okay. So just do the multiplication straight away. You'll end up getting the answer. So you would have got 6 to 8, 222. Yeah. Approximation is not allowed. Okay. So 16, 1, 5, 5, 12. Okay, 1256. So again, just plug in the same value, 1256, and then 1256. That's it. Yeah, just do the addition. 6, 1, 1. This is going to be 11, 11. Yeah, 14. Do it right. Yeah, 14, 1. You would have got 2, 4, 9, 3, 139.4. Yeah, it should be like 139.4, isn't it? Yes, because I'll have to move like 3 decimal places towards the left. So if I do move that one, this value will become 139.4. Yeah. So the answer over here is 139.4, which is option 1. What at this sum should be easy. You shouldn't have any doubt in this question. So this is an easy one. Here what they're asking us to find is the distance. If I have to get the distance, I know I'll have to consider the entire path length, right? I'll have to consider the entire path. Therefore, with the case of the second hand, it has completed 30 revolution. 30 revolution multiplied by the circumference will give you the entire distance that it has covered in 30 minutes, subtracted from the second hand, the minute hand. Okay, when you look at the minute hand, for half an hour, it would have covered half of the circle, which will be the semicircle. So that should be half times the circumference of the circle. If you just do the difference between the distance covered by the second hand from that of the distance covered by the minute hand, you'll end up getting the distance. You'll end up getting how far the second hand has covered more when compared to that of the minute hand, right? So that will be equal to 139.4. With this sum, if you look at the option, it should be every time when you solve the question, you have to look at the option. When you look at the option, two options are very closer. Therefore, you shouldn't do any approximation while solving this sum, right? You shouldn't have any doubt on this question. It should be simple, easy, and clear. Let's move on to the next one. This question is graphical based sum and also easy one. Here you have got the position time graph for two students A and B returning from the school to their homes are shown in the figure. Got it? They have given you the position and then the time, right? So they have given you the position at what position they are there at the given time. That's what they have given you over here. Along the y-axis, you have got the position x, how far they have traveled from the school. Okay, so that's the position. Same way, the time is along the x-axis. Got it? Are shown in the figure. What I'm supposed to find over here is I just have to compare this one with the options that they're given over there. So you've got like four different options. So that's not the final answer. Okay, so they've given you like five different conditions over here. What I need to select is choose the correct answer from the options given below. Got it? So here, if you look at the option here, you've got something like this: A, C, and D. So which one is correct from the options that they have given, from the condition that they have given in the question? Okay, so accordingly, I'll have to choose it. So I'll have to read this one correctly, which is choose the correct answer. So I'll have to get the correct statement from these four conditions. Got it? So first, let me verify the first condition, which is A lives closer to the school. Okay, so A lives closer to the school compared to B. The next one is like B lives closer to the school. So from these two conditions, one has to be true. Let me verify it over using the graph. So here, if you look at the graph, along the y-axis, the distance is plotted, right? If you just look at the graph, it is obvious that A started early. So when time t was equal to 0, A started walking away from the school, whatever it is. It could be any mode of transport, that doesn't matter. He started moving away from the school, and then he took like time t, and finally he reached his home. Okay, which is at a position that's gonna be at this position. Okay, if you look at the B, he didn't start when A started moving away from the school. I mean, when A started leaving from the school, that wasn't the time where he started leaving the school. Instead, he waited some time in the school, and then after some time, B started leaving the school, and then he reached the home, okay, at some time t. And by the way, he reached the home earlier when compared to that of the A, which means his mode of transport is faster, quicker when compared to that of the A. By the way, he also reached much more greater distance when compared to A. It is obvious because the x over here is greater for the B when compared to A. Therefore, if you look at the statement that they've given in the question, it has to be clear. A lives closer to the school compared to that of the B. Okay, so therefore condition A is correct, or option A over here is correct. Fine. So if you look at the final option over here, A. So you've got like three different A. Therefore, option 1 is possible, option 2 is possible, therefore, and also option 4 is also possible, right? So here A is correct, B is wrong. Then let me consider the option C. Here you have got A takes lesser time to reach home. So A takes lesser time to reach home. That's not the case, because A takes more time to reach home, because before that itself B has reached the home, right? So B lives farther away from the school. Same way, his mode of transport is quicker when compared to that of the A. Got it? Therefore, A takes lesser time to reach home is wrong. So that too is not possible. So this one is also not possible. Then A travels faster than B. No, that too is not possible. Yeah, it is obvious, right? Because he took more time to reach the home when compared to that of the A. And with the case of the B, he started late. Still, he was able to reach the home earlier. Therefore, B travels faster than A. That should be the correct statement over here. So E is also correct. Therefore, A and E is correct. Got it? Only these two options are correct, which is A and E. Let me verify it with the final option. A, C, and D only. That's not possible. A, C, and E is not possible. B and E is not possible. A and E only is the right statement. Got it? The answer over here is option 4, right? So this is simple one. You shouldn't have any doubt on this question. Yeah, straight away, easy logic based question, right? Let's move to the next one. Let me read the next question. Here you have got two trains A and B of length L and 4L are traveling in a tunnel of length capital L. Here you have got two different trains, capital A and capital B, of length L and then the 4L. Got it? So A train is shorter when compared to that of the B train. So the length of the tunnel is capital L. Okay, so you have got like two different trains that is traveling into the tunnel in parallel tracks from opposite direction with velocities. Okay, so you have got parallel tracks and they are traveling in opposite direction. Yeah, here and this is not a relative velocity based question, so do not want to worry about this opposite direction. That wouldn't be of any use for solving this question anyway. In parallel tracks from opposite direction with velocities 108 km per hour. So A train is traveling with the velocity of 108 km per hour. With the case of B train, it is traveling with a velocity of 72 km per hour respectively. Got it? Fine. So then you have got if train A takes 35 seconds less time than train B to cross the tunnel. So it should be obvious because train A has more velocity into it, same way it is shorter when compared to that of train B. Therefore, train A will take less time when compared to that of the train B, right? If train A takes 35 seconds less time when compared to that of the train B to cross the tunnel, then the length capital L of the tunnel is. So what I need to get is the length of the tunnel. So to get the length of the tunnel, they have given you the relation. Capital L will be equal to 60 times the small l. Okay. So once you get this small l, you'll end up getting the capital L. That's it, finished, right? So to solve this question, the logic that you need to know is first I just need to know how much time does a particular train takes to completely cross the tunnel. That's what I need to get with respect to the train A and then the train B. If I just know the time difference, the subtraction of those two time difference will give you 35 seconds because they have given you that one, right? One is taking less time when compared to that of the other. So just do the subtraction of the greater time with respect to the smaller time. You'll end up getting 35 seconds, right? So just do the solving. You will find the small l. If you get the small l, 60 multiplied by the small l will give you the capital L. That's going to be the length of the tunnel, right? With the case of this question, opposite direction isn't going to give you any significance while solving because here I'm just not going to consider the relative velocity things of that sort, right? That's not needed anyway. Got it? So first, before solving this question, if you look at the option, it should be clear that everything is in meters. But if you look at the velocities that they have given in the question, it is in kilometer per hour. Okay, so first I'll have to convert this one to meters, then I'll be able to do the solving. Got it? Let me get the velocity of the train A. Velocity of the train A will be equal to 108 kilometer per hour multiplied by 5 by 18, right? If you multiply it with 5 by 18, you'll end up getting the answer in meter per second, or else you'll have to do this conversion, which is like in the numerator, you'll have to multiply it with 1000 divided by 3600. Do the cancelling step, you'll end up getting 5 divided by 18. So here you would have got 5 divided by 18, that will give you meter per second. Okay, so here let me do the solving. If I just do the solving, you would have got 10818, isn't it? Yeah, let me choose and let me solve it in multiples of 3. So I would have got 5, no 6, right? 6. Here you would have got like 3, 18 will give you like 6. So that's gonna be, it's like 6. So 6 into 5 is gonna be 30. Velocity of A will be 30 meter per second. Train A will be 30 meter per second. It should be obvious then. With the case of velocity of B, for the train B, that will be equal to 72 multiplied by 5 divided by 18, isn't it? So if I do the solving, you would have got 72 same way with multiples of 3, 6, and then here it should be like 2, 12 will give you 24, and then here would have got, yeah, 6, right, 4. So 5 into 4 is going to be 20. Velocity of B over here is 20 meter per second. Velocity of A was 30 meter per second. Same way velocity of B was like 20 meter per second, right? Now I have got the two different velocities in terms of meter per second. Next, what I just need to get over here is, let me consider one of the train. Yeah, you have got a tunnel. The length of the tunnel is L. Got it? And then you have got a train. Let me take the first train, which is train A, which has a length small l. And then you have got train, which has like small l length. Okay. If this entire train has to come from the other side of the tunnel, it should have covered a distance of L with respect to the tunnel. So at that position, this front end of this train will be at the other end of the tunnel. This train has to come out of the tunnel, therefore it has to cover its own distance, which will be like small l. Okay, so this entire train, if it has to come out of the tunnel, it should have covered a distance of capital L plus small l, right? You should have covered a distance of capital L plus small l. So this is the distance or displacement that this train is going to cover to completely come out of the tunnel. Got it? So if I have to get the time, what should I do? I know the velocity, so the time will be the velocity will be length divided by time, then time will be length divided by the velocity, right? So the time taken by the train A will be equal to, that's a straight away one. Time taken by the train A will be equal to the length of the tunnel plus length of that particular train divided by its velocity. What was the velocity of the train A? It was equal to 30 meter per second, isn't it? Yeah, it was equal to 30 meter per second. So that gave you the time of the train A. Then the time taken by the train B, the same way, it should have completely crossed the tunnel and it should be at the other end of the tunnel, and then it should cover its own distance. Therefore the own distance of the train will be 4l small l. So that will give you plus 4 times small l divided by the velocity. What was the velocity? It was equal to 20 meter per second. Okay, right? So if you just look at this option, it should be clear. Time B will be greater when compared to that of the time A. Yeah, right. Even in the question they have given you clearly, train A takes 35 seconds less time, which means the time taken by the train B will be greater when compared to that of the time taken by the train A. So the difference between TB minus TA will give you 35 seconds, right? So that's the logic. Yeah, let me do it. It should be clear. So here you've got L plus 4L divided by 20 subtracted from capital L plus small l divided by 30, which will give you 35 seconds, right? So the difference was 35 seconds, so it should be 35. Just do the solving, you'll end up getting the answer, isn't it? Here, if I have to do the solving, we have got like two different variables, which is capital L and then the small l, isn't it? I just know the relation, which is capital L will be equal to 60 times the small l. Okay, so with the case of capital L, I would be able to substitute 60 times the small l. That too is possible, or else I would be able to, I'll be able to substitute L divided by 60 in this situation, right? So whatever the case it is, I just need to find the length of the tunnel, isn't it? So to get the length of the tunnel, let me substitute it in this fashion. So L will be equal to 60, L, capital L divided by 60, right? Capital L divided by 60 will give me the small l. Got it? Yeah, just do the solving, you'll end up getting the answer. Fine. So here L plus 4 capital L divided by 60, and then it is completely divided by 20 or subtracted from this one. Or else let me do it in the next step itself. So negative subtracted from capital L plus small l. So L plus, instead of small l, that's gonna be L divided by 60 divided by 30, which will give you 35, isn't it? Now let me move this 20 denominator inside these two fractions. Therefore, you will have L divided by 20 with the first one, L divided by 20. With this case, these two stuff will get cancelled out, isn't it? This is gonna be 2, and here it's gonna be 30. Yes, then one more 20 to it. That will give you again 60. So together you'll end up getting plus L divided by, so again 2 by 60 will get cancelled out, and then you'll be left with L divided by 30 once again. Therefore the next term over here is plus L divided by 30. Okay, it should be clear. So let me put a bracket over here. This entire term will get subtracted, right? So you have to do the inner multiplication for the negative sign. The third term will be negative L divided by 30, right? So it should be negative L divided by 30. Then again one more negative sign into it, that will give you negative L divided by So if you do the multiplication over here, you would have got 6 into 3, that's going to be 18, and two zeros, 1800. I've made a mistake over here, which is 20. Yeah, it should be like 20 into 30. That should have given you like, no, it should be like 10 into 30. That should have given you 300 in the denominator, right? That was the mistake over here. Okay, so which should be equal to 35. Yeah, just do the solving of all these stuff, you'll end up getting the answer, right? That's it. Let me do the solving for this one in the next page, you'll get the answer. Now let me factor out L and then I'll do the solving. So if I do factor out L, yeah, so the LCM for this one will be 1800, isn't it? Yeah, 1800 divided by 20 will give you, zeros will get cancelled, and then you would have got like 90. 180 divided by 2, that will give you 90. So for the first one it will be 90L, and then for the next ones, next L, you would have got 5, no, 6. Yeah, 6L subtracted from 1800. No, you shouldn't have got the L, isn't it? I have factored out the L, therefore it should be 90, and then here plus 6, isn't it? Yeah, plus 6 subtracted from 0 will get cancelled, and then 180, so that's going to be 60, and then negative of 1800, right? So that should be like 1. Yes, this is the numerator that I just need to get over here. So it is something like this. 90 plus 6 is 90 subtracted from the 60 will give you 30. Okay, so then you would have got like 36. 36 minus 1 is going to be 35. Okay, so I've got the answer, which is L, 35 divided by 1800, which will be equal to 35. Therefore here 35 and 35 will get cancelled out. L will be equal to 1800 meters. So the length of the tunnel will be equal to 1800 meter, right? The answer here is option 3, right? You shouldn't have any doubt in this question. It has to be clear and obvious. So the answer is option 3, right? So what I did in this question is you've got like two different trains. It is going to cross the tunnel. So the total distance covered by the train will be equal to its own length plus the length of the tunnel. That will give you the total distance. To get the time, what I need to do is the length divided by the velocity will give you the time. Okay, so now I've got the time. So you know the time of two different trains. Got it? So the higher, the more time minus the less time. If I do the subtraction of those two time interval, I'll end up getting 35, which they have given you in the question. Next stuff is just the solving one. Just do the solving as quick as possible. You'll end up getting the answer. That's it, finished, right? You shouldn't have any doubt in this question. It has to be easy. Let's move to the next one. This question is based on average speed. Here you have got an object moves with speed v1, v2 and v3 along a line segment AB, BC and CD respectively. What they have given is you have got an object which is moving along whatever direction it is, but it is one dimensional. So it is moving this segment with three different variable speeds. Okay, so it was v1 for the interval a to b, and then for the interval b to c it was v2, and then for the interval c to d it was actually equal to v3 velocity. Okay, so that's what they have given over here as shown in the figure. Then the next hint that they have given us is AB equals BC. Fine. So if I'm just going to consider it in this fashion, X for AB, then for the BC it will be equal to X, right? And then for AD it is equal to 3AB. Okay. So AD is just the total distance. So the total distance was equal to 3 times AB. Okay. So it should have been something like this. AD will be equal to 3 times AB. What was AB? AB was equal to X. Okay. So to get the CD, it should be equal to AD minus AC. So that should be 3x minus 2x, which is obviously x, isn't it? Therefore, even for the CD, it is still equal to that of the AB or BC, but they've given you in a different fashion. That's it, right? So whatever 4x or 5x, whatever they would have given you for AB, whatever they would have given you, just put 4x negative of 2x will give you like 2x, right? So that should have been the distance for the CD. In this situation, all the intervals are equal. Okay, so for the CD, the interval was equal to x. That is done. What they are asking us to find is the average speed of the object will be. So I just need to get the average speed. So to get the average speed, here it has traveled with three different velocity and it has covered a distance of AD, which was equal to 3x. Okay, so that is done. So to get the average velocity, average speed, what I need to know is what was the total distance covered divided by the total time taken. So if I just divide those two stuff, I know if it has traveled with that same particular velocity, it would have covered the same distance with the same time with the situation that they're given over here, right? So to get the total distance divided by the total time, I just know the total distance. Total distance is obviously 3x. That is done. So to get the total time, I just need to know the individual time. Okay, for the first for the first for the first velocity, which was equal to v1. Okay, so the v1 velocity v1 will be equal to time distance divided by the time. So the distance was equal to x divided by the time, isn't it? Time will be like t1. Yeah, v1 divided by t1, isn't it? Yeah, obviously v1 divided by t1 with the case of first interval. For the rest two interval, it was the same x, but the time is going to be different depending on the velocity. Therefore, for the v2, it will be equal to x divided by t2, and then for the v3, that will be equal to x divided by t3. That's it, right? So to get the total distance divided by the total time taken, you would have got, for the v average, you would have got total distance divided by the total time taken, right? Yeah, so that in the numerator, that's going to be 3x divided by the total time taken will be x divided by v1 plus x divided by v2 and x divided by v3. Therefore, that would be x divided by v1 plus x divided by v2 plus x divided by v3, right? Just cancel all those x. Just factor out and cancel it. You'll end up getting the same thing. Yeah, in the numerator, you have got like 3. Yes, that's it, finished. One more extra step to it, you'll get the answer. So here, what you would have got is 1 divided by, in the denominator you would have got v1, v2, v3. In the numerator, you would have got like v2 plus v2, v3. Yeah, isn't it? v2, v3, same way here. For the next term, you would have got v2 will get cancelled. So you would have got like v1, v3. That will be v1, v3 plus. For the third term, it will be v1, v2, right? Just do the flipping, you'll get the answer. So the answer over here is 3 times 3 multiplied by v1, v2, v3. Okay, divided by v1, v2 plus v2, v3 plus v1, v3, right? So this is the answer that I just need to mark in the option. So that's gonna be this one. Option 2 is the answer over here. Yeah, right. You shouldn't have any doubt in this question. This is an easy one, right? We might have already seen these kind of sums with 2 different velocity in the need. Here it was like 3 different velocity, right? In the need based question. So here how I should actually solve is just get the total distance and then get the total time taken, right? Put the total distance in the numerator divided by the total time taken in the denominator. With the case of total time taken, that will be x divided by v1, x divided by v2 and x divided by v3. Just do the solving, take the LCM, you'll get the answer. That's it, finished, right? It should be clear. Let's move to the next one. This question is based on differentiation. Let me read the question. The relation between time t and distance x for a moving body is given as t equals mx squared plus nx. They have given you the equation that is relating between the time t and then the distance x, okay, which is a quadratic equation that they have given over here, and where m and n are constants. So m and n are actually constants. What they're asking us to find is the retardation of the motion s. So I just need to get the retardation. So what is meant by retardation? It is negative acceleration. So While solving this one, you'll get the acceleration in negative. Got it? But they have given you clearly it is retardation, which means the answer has to be positive. Okay, so if you just look at the option, it will be clear that you do not have any negative signs into it, which means the answer is going to be positive. But the acceleration is negative because in the question they have clearly given us it is a retardation. Got it? So while solving, I'll end up getting the negative a. Got it? So that is why it is called as negative acceleration, which is retardation, right? This notion has to be clear. We have already discussed this one in the theory part, so you shouldn't have any doubt. First, let me get this equation. I'll do the first differentiation. I'll get the velocity. Then I'll do the double differentiation, and then I'll get the acceleration. That's it, right? Just do the double differentiation. You'll end up getting the answer. And then based on the answer, you'll have to plug and play with the velocity v and x to get the option matching with this one. Okay, to get the answer matching with this option. Okay, first let me get the equation, which is t, that will be equal to mx square plus nx. Okay, I'll have to differentiate this one. So differentiating the above equation with respect to the time t, right? Let me differentiate this one. If I do differentiate this one, you'll have differentiating time with time will give you 1, right? Yeah, because in itself is time. Dx by dx will give you 1. Both those will get cancelled out. Same way here, it was time. So dt by dt is 1, which will be equal to mx square plus nx, isn't it? So let me do the differentiation over here. You would have got m instead of x dx divided by dt, right? So this is a variable with respect to time that changes with time. So x is a variable, right? So if I have to differentiate this one, you should do it in this fashion, right? 2x dx by dt, right? You should get this stuff. So if I'm just going to differentiate this one with x, that will simply be 2x. But here I'm just differentiating it with time. X is also a variable, so this is a chain rule that you might have studied in your math class. So that's going to be like 2x. Okay, and then if it was differentiation with respect to x, that's it, finished. Multiplied by dx will give you 1, but here I'm differentiating it with time, therefore you would have got one more term, which is dx by dt. This is the velocity, it should be obvious, plus mx different n, right? Nx, differentiation of x will be dx divided by dt, right? So this has to be clear. Now let me do this one which will be equal to m, let me write it this way, 2mx dx by dt is nothing but the velocity v plus n times the velocity v. Okay, now I have found out the first equation, differential equation for the velocity. Next I'll have to differentiate it one more time to get the acceleration, right? So let me differentiate it one more time. That will give us the acceleration differentiating with respect to time. I'm just going to differentiate it one more time with respect to time. So 1 is a constant. If I differentiate a constant, it is obviously 0, right? This notion has to be clear. So 0, that will be equal to 2m is actually constant. So do not want to worry about that one. If you just look at these two terms, this is x. This is a variable, obviously. V in turn is related to x because dx by dt. So I'm just doing a double differentiation of x to get the acceleration. Therefore, v is also a variable. Here you have got two variables that got multiplied. We did see in the theory, if you have two variable that is multiplied, that's uv, right? U, to get the differentiated answer, it should be like uv dash plus vu dash, right? So that's how I'll have to do the differentiation. Therefore here it will be uv dash plus vu dash, that should be 2m instead of x. If I do the differentiation of this one, yeah, if I do the differentiation of this one with respect to time, you would have got v dash, right? So let me do it in this fashion itself. X v dash will be dv divided by dt, and then plus vu dash, v was like v, instead of u dash, eu dash, that's going to be dx divided by dt, right? So that will give you one more v. Yeah, let me write it straight away. So you would have got one more v plus this term nv. So the differentiated answer will be n dv divided by dt, right? Got it. Now I have got this entire term. I'm just ready to get the acceleration over here. So let me plug a for dv by dt. So you would have got 0, that will be equal to 2m. I'll just do the inner multiplication. So you would have got 2mx a, and then for the next one it would have been 2mv square, 2mv square plus n dv. No, that's a, right? N a. So the goal here is to find the acceleration a. So let me rearrange this one. If I do rearrange this one, you would have got 2mx a plus na, that would be equal to minus 2mv square, right? As I've told you, you will get a negative sign, right? If you just factor out a and then bring this entire term to the denominator, you would have got extra negative sign over here. So this negative sign clearly represents this is negative acceleration. But in the option, you wouldn't have got any negative sign because they have clearly stated in the question itself this is retardation. Therefore, I'll just remove that negative sign. Got it? Fine. The idea should be clear. Let me rearrange this one. So a, that will be equal to negative 2m v square divided by, yeah, negative 2m v square divided by 2m x a plus na. If you just look at the option, yeah, that's the answer anyway. If you just look at the option, everything was in terms of v. You do not have any x in this term, right? So same way, if you look over here, you have got x. I just have to remove this x. Obviously, if I remove this x, this n term will just go away. That's how it has to be. Okay. If I have to replace this x, what I should do is I just need to get this equation in some fashion, right? So here, yeah, let me do the rearrangement for this one. How should it actually come? Yeah, I've made a mistake over here. So it should be obviously 2mx plus n, isn't it? 2mx plus n. Yeah. Yes. 2mx plus n. So let me look at the equation over here. So 2mx and then n, you have got these two terms, isn't it? So if I just factor out this v, which is common in both those terms, if I just factor out this v, you will get the result. So that's going to be 1 by v will get factored out and then it comes to the denominator for the left hand side, which will be equal to 2mx plus n, right? So for 2mx plus n, I can replace it with 1 divided by v. So this entire term gets replaced by 1 by v. That gives you the final answer. So a will be equal to negative 2 m v square divided by 1 by v. That will give you minus 2 m v cube. Okay, the answer is 2 m v cube. You have to remove the negative sign because I've told you, right? This is negative acceleration, which is retardation. Therefore, the answer is option 3, 2 m v cube, right? You should be clear with this question. You shouldn't have any doubt. So the only tricky part over here is to do the differentiation. That's it. Nothing else important in this question. They've given you an equation. Just do the differentiation of that equation. First differentiation will give you the velocity, and then do the second differentiation that will give you the acceleration. Then you'll have to just plug and play accordingly to the options that they've given in the question. Okay, so if they're asking you to remove the x, then rearrange this velocity equation in terms for x and then we replace that one, you'll end up getting the answer, right? You shouldn't have any doubt in this question. Let's move to the next one. This sum is graphical based sum. Let me read the question. Here you have got the velocity displacement graph describing the motion of a bicycle is shown in the figure. So in this graph, they have given us the velocity and then the displacement. Fine. So generally they'll give you velocity and the time. Here they have given us velocity displacement. That's what they have given over here. Okay, so that graph is given. What they're asking us to find is the acceleration displacement graph of the bicycle's motion is best described by. So I just need to get the acceleration displacement graph for this particular scenario. Okay, so here the condition is initially it's the bicycle started from 10. Okay, when the position was equal to 10 meters, I mean the velocity was equal to 10 meter per second, and then it started from the 0 position. Okay, and then it just moved up. The velocity became 50 when the position was equal to 200 meters, and then same way then it had a constant velocity until it reached the position of 400 meters. Okay, so generally while doing theory we would have compared between the velocity and then the time. That was the usual graph that we generally see. But here what they've given over here is velocity and then the displacement. Got it? So whatever the case it is, if the velocity was constant, then how should the acceleration be? It should be obvious. The acceleration has to be 0, right? If you are going to have like a constant velocity, then the acceleration should be 0. If there wasn't any velocity to the object, if it was at rest, then even in that situation, the acceleration will be 0, right? This is something that we have already seen in the theory. So second part of this graph is super easy because it has to be 0. So for the interval between 200 to 400 meters, the acceleration has to be 0, right? So let us look into the option. So here in this question, you have got we have got the acceleration for this one to 18. That's not possible. Okay, same way here it was 0. Okay, this option is possible, it could be right. Same way if you look at the option 3, there also it was actually 18. That too is not possible. So it is pretty obvious these two graph is not possible to be the answer, because in the second scenario we know that acceleration has to be 0, but that wasn't the case with respect to option 1 and then the option 2. If you look at the option 4, that seems to be also correct, because 200 to 400 the acceleration was 0, right? So only stuff that I need to verify over here is option, yeah, the first part of this graph. Okay, either the answer could be option 2 or the answer could be like option 4, right? So if it was the velocity and then this time graph, then it would have been pretty easy, because yeah, this is obviously a constant acceleration motion and things would have been smoother. But in the situation, they've given us uh, the graph between velocity and then the displacement. Therefore, if I do differentiate this one, what I will get is what will I get is dv divided by dx. Okay, acceleration has to be equal to dv divided by dt, but in this situation, the relation is such that it is between velocity and then the x. Okay, so that is this another one formula that I've already told you, isn't it? Which is acceleration a, that could be equal to dv divided by dx multiplied by dx divided by dt. You should have known this one. If this was the case, then acceleration will be equal to v dv divided by dx, right? Yeah, so velocity dv divided by dx will give me the acceleration over here, right? So first I just need to get the function for the velocity v. Then if I do differentiate that one, then I'll get this dv by dx. If I do the multiplication of those two stuff, I'll end up getting the acceleration. Got it? I just know the velocity is not constant in this interval, therefore it should be an equation with respect to the straight line. Obviously this is a straight line, isn't it? Okay, so let me find the equation for this straight line. So what is the general formula that we use for the straight line? You should have known, which is y equals mx plus c, right? So the constant over here is the y-intercept, that will be 10. X over here is the velocity. No, x over here is the displacement, right? Y over there is the velocity. Same way, I just need to get the slope. So what will be the slope? Slope should be the final position minus obviously y2 minus y1 divided by x2 minus x1. That will give me the slope, right? Got it? So it should be clear. So here let me do the solving. That will be velocity v, which will be equal to y equals mx plus c, right? V equals, what should I put for the m? It's the slope. For a straight line, slope is constant, therefore y2 minus y1. So the y2 minus y1 over here is like 50 minus 10. That will be in the numerator. Okay, divided by x2 minus x1. That's the position over here, which is like 200 minus 0. So that will give you 200. Okay, that's done. It should be clear. This is a simple one, right? Y equals, which is v equals mx. So this entire time has to be multiplied by x plus c. What is the c? C is the starting position. When x equals 0, what was the v? V was equal to 10. It didn't start from the 0, therefore that's the y-intercept, isn't it? So that's gonna be 10 over here. Got it? So now I've got the 10. Yeah, right. Yes, I'm just done with the relation between the v and the x. Therefore v will be equal to 50 minus 10, that's 40. 40 divided by 200. Yeah, let me, if I do the canceling, what would I get? So this is going to be 40, isn't it? So 0 will get cancelled out. Same way, 24, that's 5. Okay, so 1 by 5x, or else you would have got x divided by 5 plus 10. Got it? So this is the relation for the velocity in that particular interval between 0 to 200, right? So this is done. Then what I'm supposed to find over here is the dx divided by dt. What will be the dx divided by dt? That's the velocity, right? Yeah, okay. So that is something that I've got. So here I've just, yeah, if I just need to, the velocity part is done. This is something that I could substitute it over here. Then you have got dv divided by dx, isn't it? So dv divided by dx, what is it? dv divided by dx. If I just differentiate this one, I'll end up getting the dv divided by dx, right? So the multiplication of this plus dv divided by dx will give me the acceleration, right? Simple one, straight away one. So let me differentiate this one with respect to x to get the dv divided by dx. Yeah, let me do the differentiating it with respect to x. Okay, if I do differentiate that one, you'll get dv divided by dx, which will be equal to 1 by 5. That's it, finished, right? So that's how it has to be. So that's gonna be 1 by 5. That's it, done. Okay. Now I'm just ready to get the acceleration over here. Therefore, the acceleration A will be equal to v dv divided by dx. So you would have got x by 5 plus 10 plus 1 by 5, right? Multiply by 1 by 5. Got it? Now I have got the acceleration. If I just do the inner multiplication, obviously this has to be a straight line. I'll end up getting the final straight line equation. So that's going to be A, which will be equal to x by 5, right? If I do the inner multiplication, you would have got x divided by 25 plus, yeah, that's 2, right? Yeah, it should be clear. Now I have got the equation for the acceleration. So it is pretty obvious. This is the straight line equation, isn't it? So I'm just left with two options, one of which has to be true. If I look at the option 2, it is pretty clear. It is curvy. So that's not possible. Curve is not possible. Okay. It has to be a straight line, right? Therefore, option 4 should be my answer, right? So that has to be verified. Yeah, obviously, option 4 has to be my answer. Let me verify it. So if x was equal to 0, right? That was the case over there, isn't it? If x was equal to 0, then the acceleration has to be 2, isn't it? So if I just substitute 0 over here, 0, then obviously acceleration will be equal to 2. Then the next interval will be for the 200, isn't it? If I have to do it for the 200, then what will I get? 200 at x equals 200. You would have got 200 divided by 25 plus 2. Yeah. So if I have to cancel this one, that has to be 4. Yeah. 25 times 4 is going to be 100. And then this is like 8. So 8 plus 2 will give you like 10. So the acceleration when the x was equal to 200 was should be equal to 10 meter per second square. Okay. So that is a type error over here. So you should have actually got 10 over here. Okay. So this is not 18. This is actually 10. Okay. So the final, when x was equal to 200, you have got the acceleration to be like 10 meter per second square, right? So this is what you just need to know. It's an easy sum, right? So only stuff that you need to know is you shouldn't use the formula a equals dv divided by dt. That will not work out over here because the relation is between velocity and then the displacement. Therefore, you have to use this one, v dv by dx. So to get the v, it's just a straight line. Get the equation for the straight line, you'll end up getting the velocity. Okay, that stuff is there. Then what I just need to know, then I've got the straight line, then I just have to differentiate it one more time to get the dv by dx, right? So multiplication of v dv by dx will give you the acceleration. So once you have got the equation, it seems to be pretty obvious that's a straight line equation. That stuff is done. So when you look at the option, only option 4 that is possible, right? I've just done one more verification to it just by getting the endpoints. When I got the endpoints, there was a type error. Okay, in this question, got it. So the question here you have got the type error, but in the examination that would have been 10, right? So that's the stuff that you need to know. Okay, so the answer over here is option 4, right? You shouldn't have any doubt on this question. It has to be clear. Let's move to the next one. This sum is a little bit tricky one. Let me read the question. You have got a car accelerates from rest at a constant rate alpha for some time, after which it decelerates at a constant rate beta to come to rest. Okay, so in this entire motion, initially the car was at rest, then it undergoes an acceleration at a constant acceleration alpha, then it reaches its maximum velocity, after which it starts decelerating at a different constant rate that was equal to beta. Okay, so initially The acceleration was favorable, then the car started slowing down. Finally, it came to rest. What they're asking us to find is if the total time elapsed is t seconds, the total distance traveled is. So I just need to get the total distance traveled in that t seconds in the total time. Okay, got it? Fine. So I just need to know if I just multiply velocity multiplied by the time will give me the distance covered, isn't it? But in the situation, if it was a constant velocity, that would have been a different case. But here, this is not a constant velocity, right? So if I just know the graph, yeah, in which pattern this is going to increase, it's obviously constant acceleration, therefore it has to be a straight line. If I just know that graph, what I could do is I could get the area under the graph, right? So to get the distance or displacement over here, okay, fine, the logic should be clear. So what I'm just gonna find over here is I'm just gonna generate a graph. Okay, once I get the graph between the velocity and then the time, then obviously I'll be able to get the displacement by just finding the area under the graph. Previously, while doing sums be from the neat patterns, okay, neat pattern sums, they will just give you the graph, and then what they will do is they'll just ask you to get the displacement. But in this situation, we have to generate the graph from the condition. Once you get the graph, then obviously these things will, I mean, the displacement will just come out straight away, right? So first let me get the graph over here. So here you have got something of this sort, which is, yeah, along the y-axis you have got the velocity, same way along the x-axis you would have got like time, multiplication of velocity, and then the time will give me the displacement. Got it? Here in the situation, the car initially started from the rest, then it has undergone uniform acceleration. If it wasn't uniform acceleration, then the velocity will be linearly increasing, isn't it? Yeah, that has to be obvious. Therefore, it will increase linearly and then it will reach its final velocity, that will be equal to v naught. Okay, it will reach the final velocity. Okay, I'm just going to give you the v naught. Okay, it doesn't matter whatever symbol that you give, it doesn't matter over here. And then what, here the acceleration was equal to alpha. Okay, and then what happened is it started decelerating. Okay, the acceleration was in the negative direction, same way it started decelerating, and then finally it came to rest. Again it came to the velocity 0, right? So this interval is going to be beta. So this one is going to be beta. Okay, so what they're asking us to find is actually the area under the graph. That's what I'm supposed to find it over here, right? If I have to get the area under the graph, I just need to know the v naught. If I know the v naught, I know this is the total time taken, right? So initially this would have been my time taken to reach the maximum velocity. This will be the time until it becomes 0, the next part. Okay, these two has different acceleration into it, therefore this is not a symmetrical triangle. Okay, this side and this side isn't going to be a symmetrical triangle. I know the total time taken is t. If I just know the denominator t, okay, anyway, if you look at the option, you have got the t over there. Okay, so the total time taken is t. If I just only know v naught in terms of alpha, beta and things of that sort, just half times v naught t will give me the displacement, right? So here to get the displacement, what I just need to know is, yeah, here to get the displacement, let me put it as s. So to get the distance or displacement, I just have to find half the maximum height over here is the v naught, okay, times the distance along the x-axis. That's going to be the total time t, right? Got it? If I just get the relation for v naught in terms of alpha and beta, I'll be able to do it straight away. So let me figure it out how to find that one. That's gonna be easy anyway. So here it started from 0 and the final velocity was v, constant acceleration. Therefore, alpha should be equal to v equals u plus ad, isn't it? Yeah. So that's gonna be v minus u divided by the time t, isn't it? Yeah. So alpha will be equal to v minus u. So that's v minus u divided by the time t. Yeah. Here in this condition, the final velocity was equal to v naught. The initial was 0 divided by the time. So the time was equal to t1. Okay. So this will give me the acceleration alpha with the first one. Got it? From that, I will be able to get, yeah, the term. So from that, I'll be able to get the t1. So t1 will be equal to v naught divided by alpha. Same way, if I do it for the deceleration, you'll get beta, isn't it? So beta will be equal to, it has to be negative. Beta, that will be equal to final velocity minus the initial velocity, isn't it? Final velocity is 0, okay, minus the initial velocity was like v naught divided by the time t2, okay. So if I just do the cross multiplication, you'll get t2, that has to be equal to v naught negative v naught divided by beta, isn't it? So what does this negative sign actually represent is you have got the acceleration to be in negative direction, okay, which means it is decelerating. Therefore here what I just need to get is the t2, right? So I obviously know this is negative acceleration, therefore if I just put a negative sign, these two stuff will become positive. Therefore t2 is something that I've got over here, right? So t2 is actually the unknown. I should know the beta was in the negative direction, therefore these two negative will become positive, right? Anyway, once you look into the graph, it should be pretty obvious that the acceleration over here is negative, right? So that's how it has to be, because if there is like two unknown stuff into an equation, you wouldn't be able to solve. Here the unknown stuff was like the t2. So to get the t2, I have just rearranged it. Therefore, beta has to be known, which should be negative, right? Anyway, you should know this one. Time cannot be negative either. So the total time over here is t equals, so the total time over here is t, which will be equal to t1 plus t2, okay. So now for the t1, let me substitute v naught divided by alpha, and same way for the t2, let me substitute v naught divided by beta, okay. Now I'm just ready to get v naught in terms of alpha, t and beta, okay. So it's done. Just factor out v naught from this stuff. If I do factor out that one, you would have got v naught, just do the cross multiplication, alpha plus beta divided by alpha beta, that should be equal to t, right? What I just need to get over here is actually the v naught, right? Because if you look into this equation, it is pretty clear. Half v naught is something that I need to change in terms of t, because in this option over there time was included. V naught is this, v naught is something that I just put it extra, right? So to solve that one, so therefore I'll have to remove this v naught. Obviously, once I remove this v naught, I'll end up getting the option over there. Okay. So if I do solve it, you would have got s, which will be equal to half multiplied by v naught. Okay. So here instead of t, I should substitute, instead of t, yeah, I should, no, instead of v naught, I should substitute t, isn't it? In terms of t. I made a mistake. Yeah. Let me rearrange this one. If I do rearrange this one, you would have got v naught, which should be equal to alpha plus beta, no, which should be equal to alpha beta divided by alpha plus beta. Yes, v naught multiplied by time t. Okay. So now I'm just ready to do the final solving, which is to get the displacement or distance covered s, that has to be equal to half. Instead of v naught, let me substitute this entire term. So you would have got, yes, alpha beta divided by alpha plus beta, okay, multiplied by time, and then you would have got one more t, because from this equation you have got the other one, so that should be t squared. So the answer over here is half alpha beta divided by alpha plus beta t square, which should be alpha beta divided by alpha plus beta, isn't it? Of alpha beta, yes, that's option 4. So the answer over here is option 4. It should be clear, you shouldn't have any doubt on this question. Okay, so the way we solved it is by generating a graph. Once you get the graph, this becomes easy for us to solve, right? So to get the graph, they have given you clearly this is a constant acceleration motion. Acceleration was also constant, same way deceleration was also constant. If that's the case, then it's easy for us to get the equation, because those two stuff are going to be straight line, right? So the final velocity, I just put it like some variable that was equal to v naught. So here I just know the total time taken is going to be the summation of t1 plus t2. Therefore initially, to get that T1, what I did is I just used this formula V equals U plus AD, the first kinematic equation, just rearranged it. I got the T1 and T2. Summation of T1 and T2 will give me the total time, right? Now I'm just ready to get the V naught in terms of T. Once I get that one, just get the area under the graph, you get the answer. That's it, finished, right? Okay. So this is little bit, yeah, twisted question. You shouldn't have any doubt on this question. Let's move to the next one. This is gonna be the last sum for this session. It will be easy also. Let me read the question, graphical based one. If the velocity time graph has shown shape A and B, so they have given you the pattern, okay, which is in the diagram in the question, what would be the shape of the corresponding acceleration time graph, right? So simple one. So what they're given over here is they have given us the velocity and then the time graph. What they're asking us to find is the acceleration time graph is something that I need to get. Fine. So if you look at the graph, initially the velocity was in the positive direction, which means the car was moving, the object was moving towards the positive x-axis. Okay. Then the velocity was decreasing slowly, which means the car starts braking, the object starts braking, and then there came a point where the direction of the velocity starts reversing. Okay. So it was reversing backwards. Okay. And then the car was moving backwards up to certain time. Okay, so this is how it is gonna be, and this line is a straight line. So if it was a straight line, then then there should have been a constant acceleration. Initially the car has certain velocity into it, so once I apply the brake to it, it started decelerating, okay, at a constant rate. Fine. So this is actually a straight line. Therefore, if I do differentiate this one, what will I get? I'll get the constant answer, right? So the differentiation of velocity with respect to time will give me the acceleration, isn't it? Therefore, if I differentiate this one, I'll end up getting the acceleration. Acceleration has to be in the negative direction because here the car was moving forward, still it was decelerating, then it started moving backwards, right? So obviously here the acceleration has to be constant because this is straight line with respect to the velocity and then the time. So if it was a constant acceleration, then if you just look at the option, only one option is possible, isn't it? Yeah, only one is possible. That's going to be option 2. Yeah, that's the only option which is possible over there. So this is negative acceleration. Then what should have happened with the case of M to B? It was increasing. Okay, after it has moved backwards, it started accelerating forward at a constant rate. Okay, from the negative direct from towards the positive direction from the negative position. Then it starts moving forward and the velocity keep on increasing. Then obviously this has to be in positive acceleration, right? The same other way around argument that I'm just gonna make for the interval between M to B. Okay, so it has to be positive. Therefore, the answer over here is option 2, right? You shouldn't have any doubt in the question that we have seen so far, right? So we have seen different graphical sums and then we did see sums that were related to differentiation and things of that sort, right? So this is how you'll get questions in JEE. So it's going to be a little bit tougher when compared to the NEET in terms of mathematical solving, but you wouldn't have any like extra concepts that you need to learn, but you just need to have that critical thinking, right? So you will get that critical thinking only if you start solving more number of sums. That's when you get that different kind of approach to solve sums, right? Fine. So these are like new patterns that I've chosen, especially for the JEE, okay, from the previous year JEE questions, right? So if you are thorough with all these different patterns that I'm going to teach you, you will get an attachment file in the description of this video, right? You can just go click it, get that attachment file. So there will be around like 30-40 sums that will also be from this previous year question in itself, right? You will obviously be able to solve those questions, right? If you have any doubt, I'll attach the solution also. Once you verify with the solution, you will be able to solve most probably all the different pattern sums from that particular chapter that we are seeing, right? Got it? You shouldn't have any doubt in this question, in this session. Everything has to be clear, right? With this, the video is completed. Bye.